Good day, ladies and gentlemen. For this video, we will be discussing what is RSA algorithm. Before we start, let us first define what is RSA algorithm. So, RSA, also known as Rivest-Shamir algorithm, an algorithm used to encrypt and decrypt messages. It is an symmetric cryptographic algorithm. Well, all know that in a systemic algorithm, we use private key and public key for encryption and decryption. While in symmetric, we only have one key for both encryption and decryption.
As we go deeper, let me show you the formula of encryption and decryption using RSA. For encryption, C is equal to P raised to E mod N, where C is the ciphertext and P is the plain text message. For encryption, we need the public key, which is E. For decryption, P is equal to C raised to D mod N, where is P the plain text. C is the ciphertext and D is the private key.
Now let us see the key generation steps. The first step is consider two large prime number of P and Q. Calculate N equals P times Q, where P and Q is based from the first step. Pi of N is equal to P minus 1 into Q minus 1, where pi of N is what we call Ehlers-Danlos function. Select public key E such that to satisfy the two condition, which is z of pi of n and E is equal to 1 and E should be greater than 1 and it would be less than pi of n. That is, we need to select one number E that is co-prime to pi of n. Co-prime are positive integers that if we divide, the answer is 1. Find the value of D or the private key such that the D times E mod pi of n is equal to 1.
Now, let us see the example of key generation steps. First is to consider two prime numbers. We will use P is equal to 3 and Q is equal to 5. You can use any two prime numbers you want. The next step is to calculate the number of n. The formula is n is equal to P times Q, where 3 times 5 is equal to 8. So the value of n is 8. Next is to calculate the value of phi of n. So phi of n is equal to P minus 1 times Q minus 1. Let's substitute the value of P, which is 3 and Q is 5. So this will be the equation. Phi of n is equal to 3 minus 1 times 5 minus 1. Phi of n is equal to 2 times 4 is equal to 8. The value of phi of n is 8. Next is to select the public key, and the condition is to satisfy the two equation, which is GCD E phi of n is equal to 1 and the value of E is greater than 1 and less than phi of n. To satisfy the condition, we can use this. So E is equal to 3 to satisfy this equation. So next is to find the value of D. So we have the formula. D times E mod phi of n is equal to 1. D times 3 mod 8 is equal to 1. Consider D is equal to 3. And 3 times 3 mod 8 is equal to 1. 9 mod 8 is equal to 1. And plus 1 is equal to 1.
So here we know public key, which is E and N, which is 3 and 15, and private key D and N, which is 3 and 15. Now we can move forward to encryption and decryption. For encryption, consider plain text is equal to 8, C is equal P 8 raised to E mod N, where E is equal to 8, which is the plain text, raised to 3, which is the public key, mod 15, which is the value of N. C is equal to 512 mod 15, so ciphertext is equal to 2. For decryption, we can use the formula P is equal to C raised to D mod N. So P is equal to 2, which is the ciphertext, raised to 3, which is the value of private key, mod 15, which is the value of N. Now P is equal to 8 mod 15. The plain text will be 8. So that is the process of RSA algorithm. Thank you, God bless, and keep safe everyone.